Okay, we have three basic types of stalls that will normally be practiced during training to familiarize us with stall recognition and recovery in particular flight regimens. The power off stalls are practiced to simulate the conditions and aircraft configuration I will most likely encounter during normal landing approaches. Power on stalls are normally encountered during takeoff, climb out, and go-arounds when the pilot fails to maintain proper control due to premature flap retraction or excessive nose-high trim. To help you understand how stalls may occur at higher than normal stall speed, your instructor may demonstrate accelerated stalls and show you associated recovery techniques. Most stalls are practiced while maintaining coordinated flight. However, uncoordinated or cross-control inputs can be very dangerous when operating near a stall. One type of stall, sometimes referred to as the cross-controlled stall, is more likely to occur when a pilot tries to compensate for overshooting a runway during a turn from base to final while on landing approach. There are a number of ways to recognize that a stall is imminent. Ideally, you should be able to detect the first signs of an impending stall and make appropriate corrections before it actually occurs. If you have a good understanding of the types of stalls, recognition is much easier. Recovery at first indication of a stall is quite simple, but if you allow the stalled condition to progress, recovery becomes more difficult. A typical indication of a stall is a mushy feeling in the flight controls and less control effect as the airplane's speed decreases. The reduction in control effectiveness is primarily due to reduced airflow over flight control surfaces. In fixed-pitch propeller airplanes, a loss of revolutions per minute may be noticeable as you approach a stall in power-on conditions. Also, a reduction in the sound of air flowing along the fuselage is usually evident. Just before the stall occurs, buffering, uncontrollable pitching, or vibrations may begin. Finally, your kinesthetic sense, ability to recognize changes in direction or speed, may also provide a warning of decreased speed or the beginning of a sinking feeling. Stall recovery. Your primary consideration after a stall occurs should be to regain positive control of the aircraft. If you do not recover promptly by reducing the angle of attack, a secondary stall and/or spin may result. A secondary stall is normally caused by poor stall technique, such as attempting flight prior to attaining sufficient flying speed. If you encounter a secondary stall, you should apply normal stall recovery procedures. The following basic guidelines should be used to effect a proper stall recovery. Number 1, decrease the angle of attack. Depending on the type of aircraft, you may find that a different amount of forward pressure on the control wheel is required. Too little forward movement may not be enough to regain lift. Too much may impose a negative load on the wing, hindering recovery. Number 2, smoothly apply maximum allowable power. If you are not already at maximum allowable power, increase the throttle to minimize altitude loss and increase airspeed. Number 3, adjust the power as required. As the airplane recovers, you should maintain coordinated flight while adjusting the power to normal level. You can usually prevent an accidental stall by knowing when you are most susceptible to a stall and recognizing the indicators of an impending stall. Unless you are practicing stalls and stall recoveries, don't wait for the stall to fully develop. Apply stall recovery techniques at first indication of an impending stall. There is one other page, 361, which goes over the load factors. Additional load factor incurred during constant altitude turns will also increase the stall speed. In fact, stall speed increases in proportion to the square root of the load factor. For example, if you're flying an airplane with a 1G stalling speed of 55 knots, the airplane will stall at twice the speed at 110 knots with a load factor of 4 Gs. Stalls that occur with g-force on an airplane are called accelerated stalls. An accelerated stall occurs at a speed higher than the normal 1g stall speed. These stalls demonstrate that the critical angle of attack, rather than airspeed, is the reason for the stall.